Welcome to Learning with Philemon. In the previous video, we saw that the modern periodic table is organized into groups and periods, and that elements in the same group have similar chemical properties. In this video, we will compare the properties of alkali metals and transition metals. Alkali metals, group 1, consists of the following elements: lithium Li, sodium Na, potassium K, rubidium Rb, cesium Cs, and francium Fr. The transition metals are the metals in the middle section. Examples of these are iron Fe, manganese Mn, and titanium Ti. Let's begin by discussing the properties that alkali metals and transition metals have in common. Most metals, alkali metals included, are conductors of heat and electricity. Heat conduction is when heat can be transferred from one side of a solid to another, as can be seen in this animation. If one end of a metal is heated, the vibrations cause the neighboring atoms to vibrate, transferring the energy. Metals can conduct electricity because their structure contains delocalized electrons. These electrons can move freely through the structure. To have electricity, charge needs to be able to move. All metals are ductile, which means that they can be drawn into a wire. Copper is a good example of this, as most electrical wires are made of copper. Metals are malleable, which means that their shape can be changed without breaking. Next, we will look at how alkali metals differ from transition metals. Alkali metals are much softer than transition metals. As can be seen in the animation, a piece of pure sodium can be cut by a steel scalpel or knife. Alkali metals have the lowest melting points of all metals. Potassium, for example, has a melting point of 63 degrees Celsius, whereas iron, which is in the same period or row, melts at 1538 degrees Celsius. Alkali metals have lower melting points because they have larger ionic radii and a lower positive charge. Metals tend to lose electrons to have a complete outer valence shell. In doing so, they form positive ions, named cations. The ionic radius is the distance between the nucleus and the outermost shell of an ion. The ionic radii of alkali metals are larger than those of transition metals in the same period. The ionic radius of potassium is 138 times 10 to the minus 12 meters, whereas the ionic radius of iron 2+ ions is 63 times 10 to the minus 12 meters. For more on trends in ionic radii, please watch the higher level videos. In metals, cations are arranged in a lattice, as seen in this diagram. The electrons that the metal lose are free to move across the structure and are called delocalized. For more details on metallic bonding, please watch the following video. The smaller the cations, the closer the positively charged nuclei are to the negatively charged electrons. This makes the electrostatic force of attraction stronger. More energy is required to overcome these forces, and the melting point is higher. The greater charge also increases the force of attraction. Potassium ions have a charge of 1+, whereas iron ions have a charge of 2+. Now let's take a look at another property. Alkali metals are less dense than transition metals. For example, potassium has a density of approximately 0.534 grams per centimeter cubed, whereas iron has a density of 7.87 grams per centimeter cubed. This can again be explained by the larger ionic radii of alkali metals. Because of their larger size, you cannot pack as many in a given space. As you can see in the diagram, you can only fit 4 larger ions on the right. This leads to a lower density. Remember that density is calculated by dividing mass by volume. Transition metals have more protons and neutrons in their nuclei, making them heavier than alkali metals in the same period. As a result, in transition metals, you get more mass in the same volume, hence a higher density. In summary, alkali metals are softer, have lower melting points, and lower densities than transition metals. To practice these concepts, check out the worksheets I have on my Patreon page. If you want to support my channel, check the donation link in the description. If you haven't already, please subscribe to my channel to get notifications for new videos. Stay curious.